Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all of you. So, in this video, I'm going to try to answer Kim's question on what is the difference between astronomy and astrophysics. This is a very good question and one that is often asked. Um, there are many ways of answering this question, right? Um, so, what I'll do, I will try to give an answer using different approaches, right? The first approach is to just look at the definition of the word astronomy and astrophysics. Now, if you look at the slide, it shows the branches of astronomy. Uh, let us start with the word astronomy, right? The word astronomy comes from the Greek word astro means star, nomi from nomos, right? Nomos simply means law. So if we want to understand it literally, astronomy means the law or the laws that govern the stars, right? So in astronomy, what we are interested in finding out is what law governs or determines or dictates the motion and the position of the stars, right? When we looked up in the sky and we see the sun rising and setting, the moon rising and setting, the stars and the constellation rising and setting, the planets rising and setting, right? When we look at all this motion in the heavens, we want to know, uh, do these objects move in a particular way? Is there a particular pattern to their position, to their motion? And if there is a regular pattern, what is that underlying pattern, right? So in a way, astronomy is interested in finding patterns in the sky, right? Because the things that occur in the sky always occur in a regular manner, right? Um, so that compels, that encourages astronomers to figure out or to seek out what is the law, what is the rule behind the position and the motion of all these objects in the sky, right? So that is the basic understanding of astronomy. Astronomy is that field of knowledge that concerns itself with studying the heavens with the aim of finding out what is the underlying rule behind the changes in position, changes in motion that occur to celestial objects, meaning to the sun, to the moon, to the planets, to the stars, right? So that is astronomy, right? And if we say astronomy is the study of the heavens, right, then we can, it is not surprising if we realize or not, it is not surprising for us to recognize that astronomy must have been a very, very old field of knowledge. I mean, um, since the beginning of time, maybe, or since the beginning of civilization, human beings have looked up to the sky and wondered, right? Uh, how do things move and why do they move in a certain way? So, in that sense, astronomy is a very ancient knowledge, it's a very ancient discipline, right? Uh, so, uh, and we think that almost all civilizations have some form of astronomical knowledge, right? Um, so once we have understood that astronomy as trying to figure out how and why things move in the sky, and astronomy as something that is very old, the next question is, what is astrophysics, right? What is the difference and similarities between astronomy and astrophysics? Okay, first let's deal with the similarities, right? One similarity is that both astronomy and astrophysics deals with objects in the sky, right? Astronomers study stars and astrophysicists study stars. Astronomers study planets and astrophysicists study planets. Astronomers study uh, the sun, astrophysicists study the sun, right? So there are similarities between astronomy and astrophysics, but there are also important differences, right? And if you look at this definition of astrophysics, astrophysics is a study into the physical and chemical conditions of celestial object, right? So In astrophysics, not only we want to know about the position or the motion of the celestial object, we also want to know um, what is the celestial object made from, right? What material make up a star or make up a planet, right? We want to know the physical properties. We want to know, when we look at the star, we want to know how massive or how hot it is, or how bright it is, right? These are physical properties of a star that we want to know in astrophysics, right? When we look at a planet, we want to know, how big is a planet? Does it have an atmosphere? What is its density, right? What is its temperature, right? These are physical properties of a planet that we want to know in astrophysics, right? So the first major difference between astrophysics and astronomy is that in astronomy, usually we are interested in knowing the position and the motion, the regular motion of sun, stars, planets, and moon, right? So we want to figure out, we looked at the sky and we see the appearance of stars, planets, and the moon and the sun changing, and we want to map how does it change its position, right? But for an astrophysicist, when they look at the sun, at the stars, at the planets, the moons, they want to know what, the physical properties of these objects. Is the sun made from the same elements that we have here on Earth, right? When we look at the planet, does it have the same atmosphere or the same temperature as that of Earth, right? Uh, so these are questions about the physical properties and chemical properties of celestial objects. So if in astronomy we want to know where something is, and how far it is, and how does it move, in space, in astrophysics we want to know what it is, right? What it is, will it change, or where does it come from, right? So these are questions involving the physical and chemical conditions or properties of those celestial objects. And if, let's say, we want to know the temperature of a star, right, we cannot simply go to the star and put a thermometer into the star, right? Or if you want to know the mass of the galaxy, we cannot find a large weighing scale and sort of weigh the galaxy, right? Or if you want to know the density of a planet, we cannot go to the planet and measure its, diameter, and then measure its mass, and then and then calculate the density, right? We cannot do direct measurements in astrophysics, right? If you want to know the temperature, or you want to know the mass, or if you want to know uh, the density of something, we cannot go out there and simply make the measurement. Instead, we have to do indirect measurement. So, for instance, if you want to know the temperature of a star, the only thing that we receive from the star is the light from the star, or the radiation coming from the star. So if you want to know about the temperature or the chemical composition of a star, we only all all the clues that we have is contained in the light coming from the star, right? So in astrophysics, what we do is to collect as much light as possible from stars, from planets, from galaxies, and then we study the information contained in that light, right? So, for instance, if you want to know about the temperature of a star, right? So, what we do, we collect the light, and then we break up the light using the technique of spectroscopy, so that we know uh, the energy contained in the starlight in terms as a function of its wavelength. And then you will remember in quantum mechanics and also in modern physics, you've learned about the wind displacement law, right? Uh, Whereby you can determine the temperature of something based on the type of radiation that the object emits. So you can apply the same thing, right? If you want to find out the temperature of a star, that is, all we need is to measure the radiation coming from the star in terms, as a function of different wavelength, and then you use wind displacement law to estimate the temperature. So that is an example of how we use physics to figure out the physical and chemical properties of a star. If you want to know the mass of a planet, in physics we know that the gravitational pull, the gravitational force of an object is related to its mass. So if you want to know the mass of something, what we can do is to see how does that object, how strong or how weak is the gravitational force produced by the object, right? So if you look at the black hole, the gravitational force produced by a black hole is very strong. So that tells us, using Newtonian mechanics, right, Newtonian physics, that a black hole must be very, very, very heavy, right? So in this case, we use what we already know about gravity to discover the mass of something. Just like in the previous case, we use what we know about quantum mechanics, about the relationship between, about quantum mechanics, about thermodynamics, to determine or to discover the temperature of something, of a hot object, right? So that is why this is called astrophysics. Astrophysics, in the sense that we are using our knowledge of physics, our knowledge about gravity, our knowledge about the atom, our knowledge about thermodynamics, to figure out the physical and chemical properties of celestial objects, right? So that's why it says here, through an analysis of its radiation. Because in astrophysics and also in astronomy, we cannot directly visit the object we are studying. We cannot go to the star, right, and sort of test its temperature and test its chemical composition. Instead, all we have is the light emitted by the star, right? So, and all the information that we want to know about the star is contained, is encoded in the light that emits. Therefore, if you can figure out a way to unlock the secret within the starlight, then we can know a lot of information, a lot of uh, physical and chemical information about the star, right? So that is why it's called astrophysics, because um, uh, in astrophysics we we apply the physics that we know to objects in space, right? So in a way, astrophysics is a kind of applied physics, right? Um, so once you know that astrophysics is basically applied physics, and in astrophysics, we use our knowledge of gravity, our knowledge of forces, our knowledge of electricity and magnetism, our knowledge of atoms, and of the nucleus. Um, that tells us that astrophysics must be relatively new, because if you look at the history of physics, we only begin to explore the atom or the nucleus, electricity and magnetism. We only begin to do that, in the 18th and the 19th century. So astrophysics cannot exist without the development without the developments in physics, right? We must The physicists must have discovered quantum mechanics first, must have discovered electromagnetism first, before it can be applied by astrophysicists. So I think a good uh, um, a good explanation of that is given by this. This is I took this from a book, The Cambridge Concise History of Astronomy. I have this book, but then what is important here is simply this bit here. This is a chapter 8 on the rise of astrophysics, on the origins of astrophysics. If you can see here, it says from antiquity to the Renaissance, the principal task of the astronomer have been to devise geometrical models that will reproduce the movement of the planets against the unchanging background of fixed stars. Right. So this is what we said earlier. Early on, astronomers are only interested in measuring the position and tracking the motion of planets and of stars. That is all they're interested in. They don't care about the physical properties, about the chemical properties of the stars, because to them, how can they know about the physical and chemical properties of the stars when they are so far away and they don't have the method, they don't have the technique to do that, right? Um, then it says here, um, in the 17th century, Kepler taught astronomers to investigate the forces causing these movements. Right, so you have Kepler's laws of planetary motion, and then Newton, with his idea of with his theory of gravity, um, told us that, well, the reason planets move in a certain way or stars move in a certain way is because they are obeying the law of gravity. Right, so the first law that is applied to astronomy is the law of gravity. Right. um, but then in the second half of the century, second half of the 19th century, right? 19th. So you can see the gap. This is Newton is in 17th century, right? Kepler 17th century, and you jump from the 17th century to the 19th century, almost 300 years jump. Um, Astronomers begin to fit prisms to telescope, and this allows them to break the light that comes from the star into its spectrum. So we can study the spectrum of stars, right? Um, so it says here, the astronomer of the Middle Ages had been a geometer, right? Early on, because you're only interested in the position and the motion of stars. So all you need is just a knowledge of mathematics and of geometry, right? But now with astrophysics, right? The late 19th century, the astronomer had also to master the skills of a laboratory physicist. So in in the 19th century, or rather in astrophysics, it is not enough for the astrophysicists to just know about mathematics, but they also have to know about physics, right? They have to know about the theory of gravity, the theory of electromagnetism, the theory involving the atom and the nucleus. So they have to know about quantum mechanics as well, right? So the theories and techniques used by physicists were adapted to the study of starlight, and this enabled the astrophysicists, right, to penetrate the secrets of the physical processes that at work among the stars to determine their motion in three-dimensional space, right? So what is important here is that astrophysicists use the knowledge of physics to understand the physical and chemical properties of celestial objects, right? And the celestial objects that astrophysicists study not only include stars, planets, nova, comets, all this, but it also includes exotic objects, like radio galaxies, galaxies that not only produces light but produces radio waves, right? They're interested in X-ray galaxies, right? Galaxies that not only produce, visible light, but also produce X-rays, right? And we know from our knowledge of electromagnetism, electromagnetic radiation, that a galaxy that produces X-ray has a much more higher energy compared to galaxies that produces radio waves, right? And we know this from our study from physics, right? We learn about electromagnetic radiation and all this, right? And then we also discover, there are infrared galaxies and there are gamma ray bursts, right? So another important distinction between astronomy and astrophysics is that in astrophysics, we are not only interested in uh, studying visible light, but we are also interested to study, the whole electromagnetic spectrum. So we study X-rays and gamma rays and infrared and radio wave. So, for instance, Dr. Adlika, she is an X-ray astronomer, right? So her specialty is to study objects using X-ray telescopes, right? So she does not use visible light telescope, but she uses X-ray telescope, right? And in order to observe X-rays, you have to put the telescope above the Earth atmosphere, right? Because our atmosphere absorb X-rays coming from space, right? So examples of objects that are studied by astrophysicists. This is another book, Astrophysics: A Very Short Introduction. It's quite a good book actually. I have the PDF. If you want, I can just share it with you. Um, as you can see here, the things that astrophysicists study, they study stars, right? They also study gases between stars, because space is not a vacuum. There is interstellar medium between stars. They also study planetary systems, right? Orbiting other stars. They also study galaxies, right? And they also study energetic processes, right? Highly energetic processes like accretion. Accretion is when an object with very strong gravity pulls material towards it, right? And that generates lots of energy, right? This is a process that supplies energy to black hole, right? Accretion is the most efficient energy generating mechanism in the universe, right? That's why black holes are so powerful, right? Because they have a very efficient engine. And then we also, astrophysics also deals with relativity, right? Because most of the processes in astrophysics occurs at very high energy. So particles accelerated to very high speed. So you need special relativity to understand what is happening. Okay, so roughly that is the distinction between astronomy and astrophysics. Um, Astrophysics comes later, right? Astrophysics needs to wait for physics to mature, right? It needs to wait for the theory of gravity to be introduced. It needs to wait for the theory of electromagnetism to be introduced. It needs to wait for quantum theory to be introduced before you can have astrophysics, right? But astronomy, that has been going on for hundreds of years, since the beginning of civilization. Okay, so roughly that is the distinction between astronomy and astrophysics. If sometimes when somebody asks me what is the difference between astronomy and astrophysics, I would simply answer, well, astrophysics comes later, right? Astronomy comes first, right? That is a very simple answer to a very good and very broad question. Okay, so I hope that helps. Thank you very much.